Hello, everybody. Welcome to another video. Last time I went a little bit fast on computing areas of regions in polar coordinates. So, what I thought I would do today is go over a few examples in detail about how to compute areas of different regions in polar form and the process of formulating the integrals and computing them as well, right? So recall last time to compute the area of a region in polar form. So the area um, is equal to 1/2 times the integral from, let's say, alpha and beta of f of theta squared d theta, right? And this is where we will have one curve, let's say r, which polar curve is defined by f of theta, right? And so let me illustrate this. And the angles, which is the limits of integration, right? They are alpha. Alpha is the smaller angle. And then this is theta is equal to the bigger angle, beta. All right. So let me write it down here. Okay. If you have a region that is in between two polar curves, so something like this. So, and let's say something like that, right? And you want to compute the area of this region right here, right? That region, alpha, and this is beta, okay? These polar curves are defined by, let's say, f of theta, and then this is g of theta here, right? So the area of this region is equal to 1/2 times the integral from alpha to beta of f of theta squared minus g of theta squared. Essentially the top minus the bottom curve that you've seen in Calc 1, right? So the area that I'm talking about here in this example is this pizza slice right here, right? And this bigger angle is theta equals beta, right? Okay, so yeah, so this integral refers to, or actually these integrals here, they refer to taking the area of a section of a circle, right? Okay, and to compute that area, well, it's equal to 1/2 times r squared theta, right? So this is the area of the section of the circle in radians. Okay. Part of this work is drawing out the polar graphs and then uh, computing where exactly the limits of what exactly the limits of integration would be, right? So let's do a few examples. So if I want to compute the area of the following regions, okay? So suppose I have this example. So the region inside the circle r equals a times sine theta. Okay, first of all, we have to figure out how to graph this, right? How to draw the polar graph of 8 sine theta. And then after that, we'll formulate the equation of, I'm sorry, the integral for computing this area. All right, so I'll give you a few minutes to work out this example, right? Pause the video and see what you think. All right, I guess you had time. Let's actually go over how we would formulate this. So the thing is, we want to draw out first the usual sine or cosine curve of 8 sine theta, right? So part of that is recognizing what the amplitude is, what the period is, right? And if we have any phase shift or vertical shift, right? So the amplitude is the number in front of the, which is multiplied by the sine or the cosine function. So the amplitude is 8. The period here is just 2 pi, right? We don't see a number that's multiplied by theta, right? So the period is 2 pi, right? And so from there, we can formulate or draw the usual sine curve, right, of 8 sine theta, right? Amplitude is 8. So and this is your usual sine graph, right? Just like that, right? Okay, so the next thing we want to do is draw out this polar graph, right? So the vertical axis determines the radius, right? So the vertical axis determines the radius, and this axis here is theta, right? So our polar graph, right, will have the circle of radius 8, right? So we want to draw in a circle of radius 8. All right. And then our polar graph, I'll draw this out. Yeah, in the same color. And let me label out these axes in a different color. Darn it. Just see what it looks like. Okay. So on the positive x-axis, so it's 0. Positive y-axis is pi over 2, right? So this is pi, and then 3 pi over 2 is over here, right? Okay. So to draw out this polar graph, well, we know that the radius goes from 0 to 8 when theta is increasing from 0 to pi over 2, right? So so it starts here at the origin, and then it increases up to 8, like this, right? So it's going this way. When theta goes from pi over 2 to pi radians, our radii is decreasing, right? From 0, so it's going to go this way. And do you see what's going to happen? Well, when pi, so when theta is between pi to 3 pi over 2, our radii is negative, right? So that means we have to flip our direction where we draw our polar graph, right? So essentially we're at the same curve again, right? And then at 3 pi over 2 to 2 pi, we are back to 0, but going in this way, right? So really, it's going to be this circle, right? So it's going to be a circle of radius 4. That's interesting, right? So this pink circle right here, this is a circle of radius 4. That's pretty cool. So if our if we did integration right, we should be able to get 16 pi, right? So let's see if that works, right? So the area in terms of the integral, well, okay, here's how we're going to do it. Here's one way. We can use symmetry on the circle to figure out the area of half of the circle and just multiply it by 2 to get the area of the whole circle, right? So what I'm going to do is, so I'm going to start off, so this piece of the circle, this right hemisphere, it corresponds to this piece right here of our sine graph, right? So, or I should say, let me erase this part. That's the other half. So really it's corresponding to this half, right? So our limits of integration would be from 0 to pi over 2. So really I can multiply 2 of the integral of, so 1/2 times the integral from 0 to pi over 2 of 8 times sine theta squared d theta, right? That's how you would formulate it, okay? And so this equals to the integral from 0 to pi over 2 of 64 sine squared theta d theta, okay? And then to integrate sine squared of theta, we're going to use the half angle formula, right? So this equals to 64 times the integral from 0 to pi over 2 of 1 minus cosine of 2 theta over 2 d theta, right? And so this equals to 32 1 minus cosine of 2 theta d theta. Okay. And so this equals to 32 times theta minus 1/2 sine 2 theta. And we are evaluating this when theta equals 0 on up to theta equals pi over 2. And so this equals to 32 times pi over 2 minus 1/2 times sine of 2 times pi over 2. And then if I do another parenthesis minus 0 minus sine of 0 is 0. So we'll have 0 here, right? Sine of 2 times pi over 2, right? That's just 0, right? And so this would equal to 16 pi, which is essentially what we needed, essentially what we verified, right? Okay, so this would be the diameter, so the radius is 4, so it's 16 pi, and then we have it. Okay, so hopefully that made sense. Here's another one. So we want to figure out the area of the region inside all leaves of the rows r is equal to 3 times sine of 2 theta. Okay, try to figure out how to compute the area of this region, right? And that will constitute drawing in the polar graph of 3 sine 2 theta. Um, um, and then we'll be able to formulate a interval from there, right? So pause the video and try to work on this. Okay, so I've assumed that you've computed this problem. So we want to figure out the region inside all the leaves of the rows 3 times sine of 2 theta. So first of all, it's helpful to draw out the sinusoidal curve of this function, right? 3 times sine of 2 theta. The amplitude, right, is the number in front of the sine, the number that's multiplied by the sine function. So amplitude is 3. The period, right? So the period is equal to 2 pi over 2. 2 being the number in front of the theta. So it equals to pi. Okay. So so the period is pi. So what that means is we're going to have 2 phases, right? Pi, and then let's say 2 pi is over here. And so the hash marks will be at pi over 4, pi over 2, and then 3 pi over 4, and then pi, and then 5 pi over 4, 6 pi over 4, 3 pi over 2, and then 7 pi over 4, and then 2 pi, right? Our amplitude is 3, so what, 3, and then minus 3 here. So this will be 1 period. And then another period is here. Okay. And then we're going to label out sine of 2 theta. So it'll look like this. Connect the dots, right? Just like this. Okay. So that's how you draw out the sinusoidal curve, right? For 3 sine 2 theta. Okay. So the number of roses, if the number in front of theta is even, okay, if I just look at sine of n theta or cosine of n theta, this is how you determine the number of petals. Okay, so the n is even. This means the number of petals will be 2n. Okay, 2n petals. On the other hand, if n is odd, you'll have n petals. Good thing to know, right? N petals. All right, so we're going to have 4 petals here. Okay, if you don't believe me, I'll illustrate it on this graph here. So on the polar graph. Okay. So on the polar graph, so what we need is at most the circle radius 3. Okay. So we're going to have a circle radius 3 here. All right. And also we need to label out our notable angles, right? So we'll have 0, pi over 4, and then pi over 2. And then we'll have 3 pi over 4, and then pi is here. 7 pi over 4, thrice pi over 2. I'm sorry. That's 5 pi over 4. 5 pi over 4 and 7 pi over 4 is over here. Okay. And 2 pi's there. All right. Great. So now let's get on to with the drawing in our polar graph. So when theta goes from 0 to pi over 4, it's positive. The radii is positive. So we're going to go in this direction here, right? Going in that direction. When theta goes from pi over 4 to pi over 2, our radii is decreasing. So it's going to go this way. So that way, right? Okay. So this is one petal. When theta goes from pi over 2 to 3 pi over 4, okay, our radii is negative, right? So that means we're going to go off in this direction, right? And then when theta goes from 3 pi over 4 to pi radians, we're back to 0. So it's going to curve back this way to 0. So that's the other petal, right? When theta goes from pi to 5 pi over 4, it's positive. So we're going to go in the usual direction. Okay. Like this. And then when theta goes from 5 pi over 4 to 3 pi over 2, we are back to 0. So this is the other petal. And the last petal would be over here. Be this way. Okay. So this is the polar graph for r is equal to 3 times sine of 2 theta, right? So that's the polar graph for 3 times sine of 2 theta. Okay, so those are your 4 petals. Now, what we want to do next is figure out the area of the region inside the petals. So all we have to do is figure out the area of the region inside one petal and just multiply by 4. So namely, I'll figure out the area of this petal in pink, right? So we can use symmetry, right? If you notice, each of these petals, they're made of 8 halves, right? Okay, so like this is one half of the petal, this is the other half, this is another half here, the other half is over here, this is the other half, 6, 7, and then 8, right? There are 8 halves. So another way to do this is formulate the area integral like this. So area is equal to 8 times the area of 1/2 of these petals. Okay, 1/2 of these petals. So our integral will go from 0 to pi over 4 of 3 times sine 2 theta squared d theta, right? Okay. All right. So this equals to 4 times the integral from 0 to 4, 4 times the area integral from 0 to pi over 4 of 9 times sine squared 2 theta d theta. Okay. All right. And so this equals to 36 times the integral from 0 to pi over 4 of sine squared 2 theta d theta. Okay. All right. Using the half angle formula, you'll have 36 times the integral from 0 to pi over 4 of 1 minus cosine of 4 theta over 2 d theta. And so that equals to 18 times the integral. We haven't integrated yet, so that'll come shortly. 1 minus cosine of 4 theta d theta. Now here comes the integration. So this equals to 18 times theta. Minus let's just say 18/4 sine of 4 theta. And this evaluates from 0 to pi over 4. So this equals to 18 pi over 4. Okay. Minus 18/4 sine 4 times pi over 4. The middle term, the lower term, excuse me, that would be 0, right? Sine of 4 times pi over 4, which is sine of pi, so this right here, oops. So this right here is sine of pi. That's 0, right? So this quantity right here, this would be 0. And so what we will end up with is 18 pi over 4, or 9 pi over 2. Okay, 9 pi over 2. All right. Let's look at another one. So this time, we're going to look at this region. R equals cosine theta. Okay, so as a reminder, okay, so this would be the cosine graph that you should all know and be aware of, right? So pi over 2, and then rise pi over 2, and okay. Okay, so you should all be familiar with the curve for cosine of theta, right? That's what it looks like, right? And what we want to do is figure out the area. The area of the region which is inside the circle made by cosine theta and the circle r equals 1/2, right? So, okay, we'll have the circle r equals 1/2 here. And then draw on another circle. R equals 1, right? R equals 1. The amplitude is 1 for cosine theta, right? So, and here is what, oh, geez. What cosine of theta looks like, right? 0 to pi over 2, we're going this way, right? Pi over 2 to pi, we're going this way, right? So you have to reflect off that point. So actually, this is so this is the graph r equals cosine theta, right? It should be a circle of radius 1, right? Circle of radius 1. All right. And another way to do this, just multiply both sides by r in this equation. You'll have x squared plus y squared equals 1. Equals x, excuse me. Equals x. And you have to complete the square in this method, and you'll have x minus 1 squared plus y squared equals 1. So that's the other way to draw that circle. But nevertheless, okay, we want the region that is outside the circle of radius 1/2, and inside the circle of r cosine equals cosine theta. And that would be this region in here. This region, and then this region right here. Okay. So what we want to do is, so this region is constricted by two curves. So what that will constitute is figuring out these points of intersection here and then right here, right? And so if you have a region between two curves, we have to figure out the points of intersection, where those two curves intersect, right? And this happens if the two curves equal to each other. So in this case, is set cosine of theta equal to 1/2, right? Set the two radii equal to each other. Where is cosine of theta 1/2? Well, if you guessed right, I believe you. So theta has to be pi over 3, okay? Or theta equals to 5 pi over 3, right? Or it could be minus pi over 3, right? Okay, or minus pi over 3. The region is it's not outside, it's inside the circle of r equals cosine theta. So typically we want to use the negative angle, right? Minus pi over 3. Okay, so those are the points of intersection, right? But like before, we can use symmetry, okay? We can evaluate the area of the upper hemisphere of this, the upper portion of this region, and then multiply by 2, and we'll get the area of the whole region, right? So notice it starts at 0, right? So the area of this whole region, well, it equals to 1/2, I should say, the area of the whole region is just 2 times the area of the upper half of the region. So it's 1/2 times the integral from 0 to pi over 3, right? So this right here is pi over 3, and this is minus pi over 3, okay? So it's going to be the top curve, cosine of theta squared, minus the bottom curve, minus 1/2. 1/2 squared d theta. Okay. And so this equals to the integral from 0 to pi over 3 of cosine squared theta minus 1/4 d theta. Okay. So the first term, I'll use the half angle formula. So the integral from 0 to pi over 3 of 1 plus cosine 2 theta over 2 minus 1/4 d theta. Okay. So this equals to the integral from 0 to pi over 3 of, so I will get 1/4 plus 1/2 cosine 2 theta d theta. And this equals to 1/4 times theta plus 1/4 sine of 2 theta. And we evaluate this from 0 to pi over 3. Okay? 0 to pi over 3. Okay, so this would equal to pi over 12 plus 1/4 times sine of 2 pi over 3 2 pi over 3, sine of 2 pi over 3 is root 3 over 2. So, so that equals to pi 12ths plus root 3 over 8. 3 over 8 plus pi over 12. Okay, and that's your answer. All right. So hopefully that worked. Hopefully that worked out for you. Let's see. So what I want you to do now is compute the area of this following region, right? Okay. So one of the leaves R is equal to cosine of 5 times theta. Okay. And if you do this right, I'll write out the answer. Okay. The answer is pi over 20 if you do this right. Okay. So make sure you do that one. Make sure you work. And let's see. Just want to double check if I have the function right. So let's see. Okay. Okay. And I want you to do this one too. So here's A, and then B is the region inside the lemacron R is equal to 4 minus 2 cosine theta. And if you do this right, the answer should be 18 pi. If you do this correctly, right? If you're still stuck on writing out these, formulating the integrals, and if you don't come up with the right solution, please let me know. And I will guide you through the process of getting to the correct answer. Okay, so this is the conclusion on figuring out areas of polar graphs. And this is sort of the material that I went over at a quick pace. So hopefully this helped. If you are stuck, please let me know. But until then, I will see you in the next video. Take care.